In this problem, you've been asked to find the slope of the line tangent to the curve. And the only way to get slope is by taking the derivative. And we're going to differentiate with respect to x because dy dx is slope. So we'll take the derivative of each term. The derivative of 3 is 0. That's equal to the derivative of negative 3y. Well, if we were taking the derivative with respect to x, we'd just have negative 3. But because the y is not the same variable as dx, we're going to have a dy dx term. Or think about, what is the derivative of y with respect to x? Well, it's dy dx. And now this is a product rule. So we've got p and q. The derivative of p, or p prime, times q plus q prime times p. Well, q is y squared, plus q prime is the derivative of the y squared term. That's 2y times dy dx, and p is 3x. This is the derivative of that original equation. Now, because we want to find slope, we're going to plug in x equals 4. Problem is we also need a y, and we don't have a y. The only way to find the y is to use the x and the original equation. So if we have 3x, which is 4, y squared minus 3y equals 3. Now I can solve for the y I'm looking for. 12y squared minus 3y. We'll subtract 3 from both sides so that now we can factor. I can factor a 3 out. 4y squared minus y minus 1 equals 0. Well, probably I'm going to be multiplying 2y and 2y. See if this will give us the negative y term. So my gut is this is again another calculator okay problem. If so, I would have just graphed to see when this is equal to 0. It doesn't factor properly, but the quadratic formula will give you zeros here. The one where y is greater than 0 is the positive root. So we would say 3, 1 plus the square root of 17 all over 8 squared plus 2 times 1 plus the square root of 17 all over 8 times dy dx times 12 minus 3 times dy dx equals 0. I already got sick of doing this without a calculator. My gut is it's not intended to be one. So instead of all these radicals, that turns out to be 0.640. Same thing here. Now as we continue on with some of the algebra, I plugged in all these numbers. Again, make sure to check my arithmetic. And so when you subtract 3 from 15, you should get 12.369 dy dx equals negative 1.23. Now we'll divide by that 12 point ... Best as I can tell, dy dx equals negative 0.0994. Most importantly, though, can you take the derivative, get it into this form, and use the original equation and your x value to find the y value? A lot of times it'll factor cleanly if it's no calculator, and if it's calculator, okay, you can just graph either one of these and find the intersection of the solutions. They've told you y is greater than 0, so that's why I picked this solution, not the negative root.